Welcome to my channel. Our topic is velocity time graph. Graphs are pivotal in solving problems in physics. If you gain mastery in driving graphs according to the question, you will be able to deduce given and hidden information and can calculate the unknowns. We are going to drive the general information about velocity in these graphs one by one. Velocity time graph A shows a straight line starting from a point on v-axis and progressing with time. For example, if the line starts from region O, then it means that its initial velocity was 0. But at time t is equal to 0, the moving body starts with initial velocity u and its velocity is gradually increasing with time. This change in velocity is same over same interval. It means that delta v is uniformly changing. The line is inclined upward, so it has a positive gradient. Gradient is also called the slope. So when delta v is increasing, it means that body is speeding up. Speeding up is the definition of acceleration. So the moving body has some uniform acceleration. In the velocity time graph B, we have two straight lines with positive and different slopes. Both moving bodies start with same initial velocity u at time t is equal to 0, but having different velocities with time t. Both lines are straight, so have uniform change in velocity. Line with higher positive slope have higher change in velocity. Line with lower positive slope have lower change in velocity, so over same time intervals. So we conclude that both bodies are speeding up at uniform and different accelerations, having higher gradient, higher acceleration, lower gradient having lower acceleration. In the velocity time graph C, we have a straight line. The body is starting from initial velocity u. Its velocity remains same over time t. It means that the body is moving with constant velocity. So delta v is equal to 0. When delta v is equal to 0, acceleration is 0. From here we deduce that moving body has 0 acceleration. In velocity time graph D, we have downward straight line. The body is starting from initial velocity u and its velocity is decreasing with time. When velocity is decreasing, then delta v change in velocity is negative. It means that body speed is decreasing, so it will generate negative acceleration. The negative acceleration is also called deceleration. In the last velocity time graph, we have a curved line starting from 0. That is means its initial velocity u is 0, but with time its velocity is increasing. This change in velocity over different time interval is non-uniform. It means that the body acceleration is also non-uniform.